Hi everyone, welcome back to PolyCloud YouTube channel. In this video series, we are covering the Microsoft Azure Administrator, that is AZ-104 certification, one of the most in-demand cloud certification in the industry. I will walk you through every Azure services from virtual machine storage and networking to identity management, policy and cost optimization with real hands-on demos and clear explanation. Complete series is designed to help you understand core Azure concept in depth, master real-world administrator tasks, prepare confidently for AZ-104 exam, and build a strong foundation for your cloud career. The best part is this entire course is completely free of cost, available end to end here on PolyCloud. I will also be uploading more Azure and DevOps and cloud courses soon. So please support the channel by subscribing and helping us to reach our first 1000 subscribers. It really means a lot and keeps this free learning going. Let's dive and explore Azure one service at a time right here on PolyCloud.
As an Azure administrator, you need to have the skills to control access to storage accounts. In this course, I'll configure storage account network access. Then I will manage storage account access keys using the portal, the CLI, and PowerShell. Next, I'll configure a storage account and Blob shared access signatures, otherwise called SASs, and I will configure a storage access policy. Next, I will enable storage account geo-replication for high availability, and I will encrypt a storage account using a customer-managed key pair. Lastly, I will manage storage account service and private endpoints. This course can be used to prepare for exam AZ-104, Microsoft Azure Administrator. In this video, I'm going to be demonstrating how to manage Azure Storage Account Network Access. What does this mean? Well, we know what a storage account is. It's a centralized enterprise class way to store different types of things in the Azure cloud, whether you're storing blobs or files, whether you're making shared folders in the cloud, whether software developers are working with storage or message queues, or whether you want basic key value table storage. All of those things can be stored in a... Now the question becomes, from which networks should access to that storage account potentially be allowed? I say potentially because you have to have access to the storage account itself, whether through a shared access signature, a storage account access key, through Azure role-based access control, whatever. But you can determine, for example, that access to a storage account perhaps should only be allowed from VNet 1, because maybe you've got some code running in virtual machines in VNet 1, and that code needs to talk to the storage account, but nothing else needs to. So maybe that's how you would do it. Or maybe you want to disable network access, whereby you want to configure something like a private endpoint where basically the storage account is visible within a given subnet only. Or maybe you want the storage account open to all networks, including the internet, for potential access. Here in the portal, I'm going to click Create a Resource because I want to examine what the default setting here is when we're building a storage account. It's actually quite simple. If I go to Storage Account for Microsoft and choose Create, right away, if I go to Networking, notice that for network access, the default selection is to enable public access from all networks. Now, from a security standpoint, that might not be great, but at the same time, I get it. In order for us as Azure administrators to use the portal like I am right now to get into that storage account to manage it, this would have to be turned on, or we'd have to have a VPN link to a VNet and enable access from the VNet, that type of thing. But it's important just to be aware that, yes, this is how it's set up. Of course, you could disable public access and use private access, which means, as I mentioned, adding a private endpoint. And even though we'll look at this separately later, if I just click Add Private Endpoint, what you're doing in the end is giving access or potential access from a specific subnet. Choose a VNet, of course. Choose a subnet. Basically, it injects itself, the storage account does, in that subnet to make it visible from that location. You still need permissions to do stuff in the storage account, as I've mentioned. Okay, let's get out of there. I'm going to close that out. Click the X. Basically, I want to go back to my left-hand navigator and choose Storage Accounts, and I want to open up an existing storage account. It's called Store Account YHZ-44. I open it up and scroll down. Under the Security and Networking heading on the left, I have an option called Networking, and this is where we can change the settings we just saw when we were stepping through how to create a storage account. I disable public network access. If I click Save, and in my notification bell icon in the upper right, it's saved that setting. Let's just go back here to our storage accounts view. Let's refresh our web browser. Let's go back into Store Account YHZ-44. Let's say I go to Containers to go look at my blob. What happens? It says this request is not authorized to perform this operation. Well, why on earth not? Because right now, the way I'm connecting to the portal, what I'm doing is over the internet. And we just disabled public access. So of course, this is to be expected. Now I can go back to that storage account, down to networking on the left again. And if I enable access from all networks and save that change, and then go back into my blob containers and try to navigate them, this time it lets me, right? But we can pare it down a little bit by limiting network access to certain VNets. Let's go do that. So in the left-hand navigator, I'll go back to networking, and I'm going to choose enabled. Now this is for public network access. Enabled from selected virtual networks and IP addresses. So down below, I can add IP address ranges from which this should be allowed, and add your client IP. The IP I am using right now as an admin. It knows what it is, of course. Yeah, I want to do that. But also I want to add an existing virtual network in VNet 1, subnet 2. I've got virtual machines running code that need to access blobs in the storage account. Okay, well that access is now allowed. Now, unlike a private endpoint, which uses the Microsoft Global Backbone Network and allows connectivity using private IPs, while we are limiting access to subnet 2, it's still going to be using the public IP of the service, meaning the storage account. Okay, I'll click Add. It's added our reference here to VNet 1, subnet 2 plus our client IP address. So instead of being open to all networks, the potential to access this storage account is now limited. I'll click Save. I'll refresh my web browser window to make sure everything's up to date. And if I go to blob containers and try to browse through that, it should work because my client IP address has been added, as well as VNet 1, subnet 2. We know that every storage account created in Azure has 2 storage account access keys. Our focus in this video, we're going to talk about how to manage those keys using the portal. Let's get started here in the portal by clicking Create a Resource because I want to step through the relationship of keys and the creation of a storage account. When you're going to create a storage account resource, so I'll just select Storage Account from Microsoft and create. All of the settings as you're creating the storage account, you will not find a reference to storage account access keys other than under Advanced where we have an option called Enable Storage Account Key Access. It means what it says. If you want to be able to allow access to a storage account instead of through an Entra ID user account, instead of that, if you want to allow access using keys, which also includes shared access signatures, that needs to be turned on. What I'd like to do is begin by examining what happens if we turn that off. Okay, so let's go back to basics, specify the details required to create the storage account. We've already seen this stuff before. So I'll call it Store Account YHZ-45. And basically, I'm going to click the Review button because there are no other changes I want to make. And we're going to click Create to create the storage account. So we've turned off allowing access using access keys. Okay, when that is complete, I'll click the Go to Resource button to open up the properties of our new storage account. And I want to go right down in the left-hand navigator under Security and Networking to access. So the point is that notice, it's still generated 2 keys and connection strings. We can choose to show them so we could then copy them and maybe provide them to other parties to give them full access to the storage account. Of course, we could also click Shared Access Signature on the left and provide more limited access to the storage account, but it still would use either key 1 or key 2, which are there. We've disabled access to the storage account using these mechanisms even though the keys were generated. So quite simply, if we, in the left-hand navigator, were to go down and select configuration, on the right, among the many settings here, there is an option called Allow Storage Account Key Access. This is where that is. So it's disabled because we unchecked the box when we created the storage account. Normally, it's enabled. I'm going to click the X in the upper right to close that. What I'd like to do is go back into my storage accounts view. I'll do that via the navigator on the left. I'm going to open up another storage account called Store Account YHZ-104. Now, this is a storage account that was created previously with default settings. So we know that if we go down to configuration, that the Allow Storage Account Key Access option is enabled. We also know that certainly, if we click Access Keys in the left-hand navigator, of course, there are two access keys, key 1 and key 2, as well as connection strings, depending on what other people might use to connect to the storage account will determine whether they need the key or whether they need the connection string. We've already mentioned there are two of these keys and connection strings because periodically, for security purposes, you should rotate. Well, if you rotate key 2, whoever currently has key 2 or its connection string will lose access because they're going to be newly generated. The old ones are invalidated immediately. However, whoever has key 1, either the key or the connection string, they're still good to go because you haven't rotated them. And that's why you kind of have two. Let's test this out. So what I'm going to do is I'm going to copy key 1 to my clipboard. There are many ways to make a connection to a storage account over the network. However, I'm just going to use the free Azure Storage Explorer GUI tool to connect to cloud storage in many different ways. So if I click the connect or the plug icon over on the left, I can choose storage account or service, account name and key. I'll click next. I'll specify the name of the storage account and I'll paste in the account key. It generates the display name. That's it. Let's check it out. Does it work? Looks good because here on the left, I'm in the Explorer. Under storage accounts, we have our storage account display name. In parentheses, it tells us we connected via key. That means the storage account. And I can start to browse blob containers and click on blobs themselves to start to manage them. It's working, in other words. But back here in the portal, let's rotate key, like regenerating or creating a new key 1. So I'm going to click rotate. It says the current key will become immediately invalid and is not recoverable. Do you want to regenerate access key 1? I'm going to click yes, and immediately it's done. So let's go back to the Storage Explorer to see how that behaves. I'm just going to click on something else here in Storage Explorer to kind of refresh it a little bit and go back, or try to go back into, let's say, my project's blob container. Now I can also right-click on the storage connection here to refresh it. And now when I try to go into blob containers, I'm getting an authentication error. And of course, that's simply because key 1 was regenerated. In this demonstration, I'm going to be managing storage account access keys using the CLI. We've talked about the fact that if we go into a storage account here in the portal, we can scroll down in the left-hand navigator where we'll come across access keys that we can click. We will have key 1 and key 2, each of which consists of a key and a connection string. You can provide either of those to other parties so that they have full access to the storage account using the key or the connection string, instead of having a user account in your Entra ID tenant. But it does give full access to the storage account. We know that we've got two keys, key 1 and key 2, so that one can remain as it is to continue to allow access to those parties that have the key or the connection string, while the second one can be rotated for security reasons, and you can kind of stagger that schedule. That way your keys aren't staying the same all of the time, and from a security perspective, periodically changing keys is a good idea. Now, naturally, we can rotate the keys here in the portal by clicking on the rotate key link for either key 1 or key 2, but here we're going to be doing it through the CLI. So I'll click the Cloud Shell icon to launch that. The first thing we should do is get a list of storage accounts. If I were to run AZ Storage account list and press enter, it returns all of the storage accounts, and as usual, all of the attributes are there. It's a little overwhelming. So I'll use the up arrow key and add -- query to that previous command. space open close square bracket dot name, and then we're left only with storage account names. I'm interested in store account YHZ44. So I'm going to run the command AZ storage account keys list -- account - name. In this case, that would be store account YHZ44 -- resource - group is HQ for headquarters -- output format of this is going to be in tabular format in a table. All right, so key 1 is shown and its value wraps down to the next line. Same thing is true of key 2. Now I'm going to keep that output on the screen because we're going to rotate key 1 and I want to be able to compare the newly generated key with the old one. We could also compare that, of course, in the portal. So I'm going to run AZ storage account keys renew -g, so the resource group is HQ -n for the name of the storage account, store account YHZ44, and -- key is going to be primary. That means key 1. I'll press enter. Now the new value for the primary key, key 1, starts with 3ZW0. So now the value for key 1 now begins with CRMB8, where previously key 1 began with MTJT5. So it's definitely changed. However, key 2, which started with 3ZW0, it remains unchanged. It still starts with 3ZW0. We didn't regenerate it. I'm going to clear the screen and use the up arrow key to get back to our renew statement, except instead of using primary for the value of the -- key parameter, I'm going to specify secondary, which of course means key 2. Enter. So now key 2 begins with DZBY. It has changed. Now remember, the moment that we do this, when you regenerate or renew a key, whoever was using the old key or connection string to access the storage account, their access will be terminated immediately. It's effective right away. And that's good because that's the purpose of this. We are renewing keys for a security reason. In case a key was compromised, well, that compromised key then would no longer be valid once we renew it. If we were to minimize Cloud Shell and go back into the portal, I'll just click on something else here, go to Access Keys, even click Refresh here at the top. When we go to show key 1 and key 2, they will reflect the newly changed values. Now, if you're in the portal and they don't look like they're updating, just refresh your web browser. But that's how we can manage storage account access keys using the CLI. In this demo, I will be managing storage account access keys let's start here in the portal by going into Cloud Shell because that's where I'm going to run PowerShell commandlets from. It took me into Bash automatically, but I'm going to click on that to switch to the PowerShell environment and I'll click confirm. And I'm going to start by running git command * storage account, another asterisk at the end. Those asterisks are wildcard symbols. So I'm checking to see if any commandlets have the text storage account in their name. And interestingly, as we scroll up through the output, one command that catches my attention, it's get -az storage account key. Well, naturally, that one is designed to retrieve the storage account keys because we know there are 2 of them with every storage account. Further down, we have new -az storage account key, which would be used, of course, to rotate, regenerate, renew, whichever word you prefer to use, existing keys. In the security community, it's generally considered a good idea to rotate keys periodically. So if for some reason a key was compromised, which could be possible without you even knowing about it, by changing keys periodically, you're keeping the environment a little bit more secure. Okay, I think we have what we need here in terms of commandlets that we want to use. I'm going to start by writing git -az storage account key -resource group name HQ. And I know that the storage account name I'm interested in is called store account YHZ40. Press enter. It returns both key 1 and key 2. Okay, That's to be expected. But what if I want to zoom in just on key 1 or zoom in just on key 2? There are a couple of ways that we can do that. Let's clear the screen, use the up arrow key to bring up that previous command, and I'm going to pipe the previous command to get -member, I'll specify -type property. I want to see what properties are available when we run get-az storage account key. Well, there's creation time, key name. Well, that's the name of the key though. Permissions and value. That's probably the key value, even though it's not called that, it's just called value. But let's make that assumption. That's the key value. Okay, so let's clear the screen. Let's use the up arrow key to go back to get AZ storage account key. Well, what I want to do is enclose that entire expression within parentheses. We know that expression works because we ran it and it returned both key 1 and key 2. We can have that execute as its own statement, but outside of the closing parentheses, now I'm going to call upon the .value property. And because we have a collection of items of the same type, that would be key values, we refer to them using array notation, which means open and close parentheses. The first item in that array is referenced as item 0, not 1. Happens. Yep, that looks like key 1. And if we use the up arrow key and call upon item 1, which is really the second item in that collection or array, that really would be the value for key 2, we get a different resultant output. Okay, well, let's say I want to generate or regenerate a new key 2 value. So key 2 right now currently starts with DZBY. So to do that, I'm going to run new -az storage account key -resource group name is HQ, -name of the storage account is store account YHZ44, then -key name key 2. Let's press enter. Let's go ahead and run our second last command. We can go through our up arrow key command history to get there, where we were displaying value 1, that's key 2. Remember, it used to start with DZBY. Press enter. It doesn't start with DZBY anymore, of course, because we've regenerated it. So it now starts with 7JIW. So we have successfully regenerated or renewed key 2. We know how this works. Anyone that previously had key 2 or the key 2 connection string and was using it to access the storage account will no longer have access using that version of the key. So then you would, of course, take it upon yourself to distribute this key 2 in a secured manner to authorized parties that should have access to the storage account. Besides 2 access keys for a storage account, we also have other options to allow authentication besides having a Microsoft Entra ID user account. And in this case, our focus is going to be on working with a shared access signature, or a SAS. You can have a SAS that allows restricted access to a storage account, but you can also get even more granular and you can have a shared access signature, or a SAS, that gives access to a single blob. We'll do that in another demo, but right now let's focus on storage account shared access signatures. In the portal, I'm going to go into my storage accounts view. I'm interested in a storage account called store account YHZ44. Navigation bar on the left, scroll down under security and networking. Of course, here we have the access key. 2 of them, so you can have one that's currently in use while you rotate the second one for security reasons. And third parties can use either the key or the connection string to get full access to the storage account, and they do not need a separate user account anywhere else. Of course, when you rotate the key, that key becomes immediately invalid. But instead of providing access to everything in the storage account, full read and write access, which is what access keys do, instead of that, we can be a little bit more specific with a shared access signature. So I'll click that on the left. What we have to consider is, to which of the 4 core components of a storage account do we want to allow access to? It could be to blobs, so just regular files that we upload. It could be for file shares. It could be for queues or tables. I'm going to turn off file, queue, and table, as I only want this shared access signature to provide access to blobs. So the blob service, blob containers, blobs themselves, I'll turn on those resource types. What permissions would you like to allow? Well, maybe I only want to allow really reading and listing, but not the addition of blobs, creation of blob containers, writing to existing blobs, deleting. We can also determine how blob versions should be treated. I'm going to remove that check mark. Same with blob index permissions, which are just other key and value pairs for blobs. I'll remove those. We can also set a start date and time when this shared access signature is valid, when it can start to be used, and we can also determine when it can no longer be used. Notice the default selection is that the shared access signature will be valid for 8 hours. You can change that. That's just the automatic setting. And it's based on a specific time zone, of course. You can also, in addition, specify certain IP addresses from which this shared access signature will be valid. And from the storage account access keys, of which there are 2, you can simply determine which one of them you want to use as the signing key to generate the shared access signature. So I'm going to click the button at the bottom labeled Generate SAS and Connection String. And when I do that, if I scroll down, we've got a connection string, we've got a SAS token, and we've got a blob service SAS URL. Well, why do I have those? Depending on which method somebody will be using to connect to the storage account using this shared access signature will determine which one of these things that they use. So let's explore that for a moment. I've downloaded and installed the Microsoft Azure Storage Explorer GUI tool, which we've taken a look at in a variety of ways. I want to connect to a storage account using a shared access signature. So to do that in this tool, I'll click the plug over on the far left. I'm going to choose storage account or service. I don't want to sign into the entire subscription with an account. So storage says, how will you connect to the storage account? A connection string, a shared access signature URL, or an account name or key. So the connection string could be one that stems from the storage account access key, which gives full access to the account. It's not what we're talking about here, but you can also use the connection string from a shared access signature, and of course the URL for a shared access signature. So let's use the shared access signature URL. And back here in the portal, to the far right of Blob Service SAS URL, I'll click the copy icon. It's been copied. And back here in the Storage Explorer tool, I'll paste that into the service URL field. It generates the storage account name. Let's click Next and connect. We are looking at our Explorer view here over on the left, where now we have an entry for our storage account, and in parentheses it says SAS. Of course, that's shared access signature. Notice that down below, all we see is Blob. If we had used a storage account access key, we would also see file shares, queues, tables, but we're not using a storage account access key. So if I go into the project's blob container, I can see these blobs, a new one. So I'm trying to upload a file called Project C, but down below under my activities panel, it says failed to start transfer, insufficient credentials. I'm not allowed to create new entries here. Also, I can't delete anything. If I go to Project A, and if I choose delete, are you sure you want to delete it? Yes. Down in activities, failed to start delete, insufficient credentials. So for the next 8 hours, this is the type of access I would have to that storage account and its blobs. And that is the exact purpose of a shared access signature. Limited or restricted access to a storage account.